There's something interesting about malaria microscopy. At first glance, a thick film and a thin film may look like two versions of the same experiment. Put some blood on a slide, stain it with Giemsa, add oil, and find the parasite and start counting. Well, not quite. The moment you ask, how many parasites are there, the thick film and the thin film take rather different philosophical approaches to the question. The thick film says, forget the red cells, find the parasites. The thick film is the workhorse when your primary question is, are parasites present? And if so, how many are there per microliter of blood? Because the blood is spread thickly, and this film is from Ernest Boahene of Begro District Hospital, beautiful slides. The red cells in a thick film are largely lysed during staining, and that's because you don't fix them before you stain. So the parasites are concentrated in a relatively small area. You use 6 microliters to prepare it. That makes a thick film considerably more sensitive for detecting malaria parasites, particularly when parasite densities are low. The World Health Organization recommends examination of both thick and thin films for malaria microscopy. But now comes a slightly odd bit. You don't normally count parasites against red blood cells. You count them against white blood cells. For routine quantification, World Health Organization recommends counting parasites against 200 or 500 white blood cells. Why the difference? If you find 100 or more parasites while counting, so your parasitemia is high, then the first 200 white blood cells you count is sufficient. You can use the 200 white blood cell count. But if you find fewer than 100 parasites, you have to continue counting so that you count at least 500 white blood cells. The calculation then becomes your parasite per microliter. So number of parasites counted divided by the number of white blood cells counted, and then you multiply it by your white blood cell count per microliter. If you don't have the patient's actual white cell count, then by convention, you can assume that there are 8,000 white blood cells per microliter of blood. So for example, if you counted 250 parasites among 200 white blood cells, then it's 250 of your parasites divided by 200 white blood cells, then you multiply it by 8,000, and that results in 10,000 parasites per microliter. The thin film, this one you're using 2 microliters, and check out these beautiful slides made by Ernesto once again. So the thin film has a different personality. Here the red cells remain intact and are spread into a monolayer. That makes the thin film much better for looking at parasite morphology and species identification. And when it comes to P. falciparum, it also allows us to express parasite burden as percentage parasitemia. Now we're interested in a different question. What proportion of the red cells are infected? So instead of counting parasites against white blood cells, we count them with reference to the red blood cells. So here we have percent parasitemia as your infected red blood cells divided by the total number of red blood cells counted. Then you're multiplying by 100 because it's percent. The CDC recommends counting at least 500 red blood cells, with more counted when necessary, particularly at low parasitemia densities. So if I examine 1,000 red blood cells and find 25 infected cells, then it is 25 divided by 1,000 times 100, and my parasitemia then is 2.5%. And here's a finer detail to note. You count the infected red blood cell, not every parasite inside it. So if one red blood cell contains several parasite forms, that red blood cell still contributes 1 infected red blood cell to the percentage. Thank you so much for checking out the video. I really appreciate you subscribing to our study group and giving the video a thumbs up. And I'm looking forward to catching you in the next video. God bless. Bye.